Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Today we will go into Chapter 22, Analytical Techniques. So we will move into 22.3 for mass spectrometry. So we got to deduce the presence of bromine and chlorine atoms in a compound using M+2 peak. So in the syllabus, we are required to know for chlorine, where we have 35 and 37 chlorine, where the ratio of them are 3 to 1. So we will have 35 chlorine to 37 chlorine with a ratio of 3 to 1. And we have to know for bromine as well. So here we have bromine 79 and 81, where the ratio will be 1 to 1. So we have 79 bromine and 81 bromine. So we will get 1 to 1 for each of them. So making use of mass spectrum, we could actually deduce the presence of chlorine or bromine atoms in a molecule. So if we have chlorine atoms into mass spectrometer, the mass spectrum that we could obtain is with two peaks. So we will get a peak at 35 and 37, so where the ratio of it will be 3 to 1. So it's the same thing for bromine atoms. So we'll get two peaks where we will get 79 and 81. So the ratio will be 1 to 1. So it shows at the heights of the peaks. So what if we have a molecule where the molecule consists of one bromine atom, for example CH3Br. So we could actually have CH3 with 79 Br, and we can have CH3 with 81 Br. So the peak for this molecule will be the same as well for the molecular ion, where we could have two peaks. So there will be a peak at 94 and 96. So the relative heights for these two peaks will be the same as well, which is 1 to 1 ratio. So looking to this, we could actually see the pattern of the mass number with the molecule or with atoms of chlorine, one chlorine and one bromine. So where we can actually see if it is one chlorine, we have the pattern of the peaks with M and M+2. So same thing goes to bromine, where if 79 is M, 81 will be M+2. So for a bromine atom in a molecule, for the molecular ion, we will also have the same pattern, which is if 94 is M, 96 will be M+2. Okay. What if we have a molecule with two chlorine atoms? So the possible molecules that we could have for chlorine molecules with two Cl atoms is actually 35 chlorine with 35 chlorine, and we could have 35 chlorine to 37 chlorine. And lastly, we could have 37 chlorine to 37 chlorine. So we could actually see 3 peaks for the molecular ion for Cl2. So where we will have a peak at 70, 72, and 74. So with the pattern of M, M+2, and M+4. So what about the relative heights? So we could actually calculate the relative heights of these 3 peaks with the probability of 35 and 37 chlorine. So the chances to get 35 chlorine is 3 out of 4. Same thing goes for this 35 chlorine, 3 out of 4. So next we'll go for 35 and 37 molecule. So we have 3 out of 4 for chlorine 35 and 1 out of 4 for chlorine 37. So we could actually switch the position of them to have 35, 37 chlorine and 37, 35 chlorine. Therefore, we multiply by 2. So the next to go for 37 and 37 chlorine. So we could actually have 1 out of 4 and 1 out of 4. So the ratio of these 3 peaks could actually go for 9, 6, 1. So we have a peak at 9, 6, and 1. So these are the relative heights for these 3 peaks with 2 chlorine atoms in a molecule. So the same thing goes to bromine molecule. So a molecule with 2 bromine atoms, we could have 79 bromine and 79 bromine, and we have 79 bromine and 81 bromine. So lastly to go, it's 81 bromine and 81 bromine. So to get the relative heights for this molecule, we could have 1 over 2, 1 over 2 for both 79 bromine. And same thing goes to this 79 bromine and 81 bromine, but we could actually switch the position, so therefore we got to multiply by 2. So next to go will be 1 out of 2 and 1 out of 2 for these 2 81 bromine. So the relative heights for these 3 peaks will be 1 to 2 to 1. So in a graph or mass spectrum for this Br2 molecule, we could actually get 3 peaks at 158, 160, and 162 for the molecular ion. So the relative heights will be 1 to 2 to 1. And the pattern for the mass number for a molecule with 2 Br atoms, it's also the same, where we have M, M+2, and M+4 peaks for the molecular ion. So with all this pattern for the mass number and also the relative heights, we could actually deduce a molecule if they have chlorine or bromine atoms in them. So let's move into this mass spectrum. So without knowing the unknown, looking into the mass spectrum of it, we can actually deduce this molecule contains 1 bromine atom. So let's move into the mass number of the molecular ion. We could actually see the pattern of it is actually with M, M+2. So if 122 is M, 124 will be M+2. So we can actually know this compound with 1 halogen. So next, with the relative heights of two peaks, which is here 1:1 ratio, we can actually deduce this molecule consists of one bromine atom. So the next to go, we can actually see there's one chlorine atom in the molecule with the mass spectrum of it. So we focus on the mass number for the molecular ion. So we have 78 and 80. So if 78 is M, 80 will be M+2. And next, the relative heights of these two peaks is 3:1. So with this, we can actually deduce this molecule consists of one chlorine atom. So besides molecular ion, so we could actually look into the peaks for fragment ions. So if the fragment ions with one chlorine atom, we could actually see the pattern of peak for the mass number with the same pattern where we have M, M+2, and the relative heights will be the same as well, which is 3:1. So in conclusion, it is the same for both molecular ion and also fragment ions if they have halogen in them. So the summary of this would be, if a molecule with one chlorine atom, so we could actually see the pattern of the mass number, it's M, M+2, and the relative heights will be 3:1. So if a molecule with one bromine atom, so it is also will have M, M+2 peak, and the relative heights will be 1:1 ratio. What if a molecule with two chlorine atoms, so the mass number will have M, M+2, and M+4. So then the relative heights of these three peaks will be 9, 6, 1. So if a molecule with two bromine atoms, so we will have also the pattern of the mass number with M, M+2, and M+4. So the relative heights for these three peaks will be 1:2:1.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.